Okay, hi, welcome back. Right now we're going to continue with Unit 5 and we're doing Lesson 3. Lesson 3 is a continuation of the idea of solving linear equations. So to solve for a linear equation, one more time, is to find the point of intersection between two lines. So we did this in our first lesson through graphing. We did this in our second lesson through a method called substitution. And now our third lesson is a method called elimination. Elimination, ultimately our goal is going to be to get rid of, eliminate, a variable, which is a letter. So in order to eliminate in math, that means to turn something into a zero. The only way that that's possible is if our coefficients are the same worth, have the same value. So what we mean by there is that the two numbers, in order to equal a zero, you have to minus by itself. So for example, if I wanted to turn a 5 into a 0, what would I have to do to that 5? I'd have to minus 5 from it. So 5 minus 5, that'll become a 0. So what we're going to be looking for is coefficients that have the same value, the same number. We're not so worried about the sign because we can always change the signs by adding or subtracting to turn it into a 0. So let's practice eliminating some variables. This is not elimination yet. All we're going to be doing right now is practicing making a variable into a 0. So with my first example here, I've got two equations, 10x plus 20y equals 80, and negative 10x plus 15y equals 25. So what I want you to do and what I want to practice right now is just turning one of these variables, either the x or the y, into a 0 by adding or subtracting. So let's think about it. In both of these equations, we have a 10x or a negative 10x. We have a 20y or a 15y, and an 80 and a 25. I'm not concerned with the 80 or 25. Those are my constants. But I've got the y's and the x's, and I need to eliminate one of them. Right now, the only one that I can eliminate would be the x. And how do I know I can eliminate the x? Because both of the coefficients in the front are 10. They're the same. So they can be eliminated by either adding or subtracting. So this is when you have to take out your calculators and test which one we have to do. So are we going to add or subtract to make that x into a 0? Let's try adding first. 10 plus negative 10 equals 0. So I don't need to try subtraction. I know right now that by adding these two terms together, I can turn that x into a 0. So then I'll continue to collect or add the like terms together. 20 plus 15y. 20 plus 15 is 35y. Then I'll collect the constants. 80 plus 25 is 105. And then if I needed to eliminate or solve, for that variable, y, the next step that I could do is to divide by the coefficient in front of that variable. So 105 divided by 35 ends up at 3. This is essentially what we're going to be doing to perform our method of elimination. Let's see another example. 9x plus y equals 4. 14x plus y equals 1. Do you think it's possible to eliminate the variables, the x's? No, because you've got a 9 and a 14. They'll never become a 0. How about the y's? Yes, you can eliminate them because the coefficients in front are the same. They're both 1. So then we'll put our plus or our minus sign, and then we're going to test which one will make a 0. So we're going to test with the y's. That's how we'll know. So right now, 1 plus 1 is 2. That doesn't work. It's not creating a 0. So then we'll try subtraction. 1 minus 1. That's equal to 0. So I'm going to circle the subtraction sign to know that that's the way that I'm going to be able to eliminate these y's, is by subtracting. So I'm going to keep subtracting all the like terms. So right now I'll subtract 9x minus 14 to end up with negative 5x. I'll bring down the equal sign, and then I'll do 4. And then here's where you have to be careful on your calculator. 4 minus negative 1, which ends up being 5. Because 4 minus minus 1 is 4 plus 1. The two negative signs turn to a positive, so that becomes 5. Now if I wanted to solve for that variable x, I would be dividing by negative 5. 5 divided by negative 5 is negative 1. So let's continue with another example. I'll put my plus or minus. I don't know which one it's going to be yet, but I can look at my variables, x's and y's, and I can see that my x's are two different numbers, 18 and 12, so that will never cancel out to be a 0, but that my y's are negative 5 and negative 5. So I know that I can cancel them out. So let's see which sign will work. Is it going to be, do I add the negative 5's together, or do I subtract the negative 5's? So let's try adding first. So on your calculator, negative 5 plus negative 5. And what answer do you get on your calculator? Negative 10. So adding doesn't work. Let's make sure that subtracting does. So on your calculator, negative 5 minus negative 5 equals 0. So then subtraction is what I'm going to be doing to collect the like terms and eliminate a variable. So now I'll start off with 18x minus 12, which gives me 6x, and then 454 minus 316 to equal 138. If I needed to solve for that x, I would be dividing by 6, which gives me an answer of 23 for my x value. Now if you go back and you think about this, what we're doing right now, we're solving for variables. That's a y, an x, and an x. So what we've been doing essentially is solving for a point of intersection and not even realizing it. We're just missing the other variable in each of these equations. Now I want you to practice eliminating variables for D, E, and F, and then check your solutions on the filled-in version of the note. So now that you've practiced eliminating a variable, we're going to add another step to this process of elimination to basically complete it. Elimination is, I think, a little bit easier than substitution because it involves less steps. So if you look at the two steps that I've written down for you, they're just simply to step number 1, eliminate a variable by adding or subtracting, which we've practiced above. And step 2, once you have that solved variable, substitute it into any equation to solve for the missing variable of your x or your y for your point of intersection, which is your solution to a linear equation. So let's see what that means. Step number 1, if I've given you these two equations, is to choose a variable that you can eliminate for. And we're going to choose to add or subtract to eliminate that variable. So right now, by looking at these two equations, 3x plus y equals 19 and 4x minus y equals 2, which variable do you think you can eliminate? If you said y, you're correct. Y both has a coefficient or a number in the front of 1. Those two 1's will make a 0. A 3 and a 4 won't. They'll always be 1 apart. So now I have to determine whether I'm going to add or subtract. So now we'll test it with the y variables. I'm going to choose to add first. Positive 1 plus negative 1 equals 0. So therefore, I know that adding these variables together will create a 0, which I'm looking for to eliminate one of the variables. So now that I know I'm getting rid of my y's by adding, I'll continue to add the 3x and 4x and the 1 and the 2. 19 and 2. So 3 plus 4, 7x, and 19 plus 2 is 21. Now I'm going to solve for that x variable by dividing what's in front, which is a 7. So 21 divided by 7 is how many times a 7 can go into a 21, which is 3 times. There, I figured out my x value. Now my next step is to figure out my y. So this is step number 1. And then step number 2 tells me to choose any equation. Doesn't matter which one. Choose the easier one though. And substitute the found variable to solve for the missing. So I'm going to choose the first equation. 3x plus y equals 19. And right now, I'm going to use this method of substitution again, but it's an easier method of substitution because there isn't multiple variables going on. So right now, x is 3. So 3 times 3, I'm replacing that x with 3, plus y equals 19. So now I'll begin to solve. 3 times 3 is 9. We're going to take the 9 and bring it over to let the y be by itself. We're collecting like terms. 19 minus 9, that positive 9 turns to a negative, becomes 19 minus 9, which is 10. And right now, you're done. You have your x and your y coordinates for your point of intersection. So all I would need to do to finish this off for full marks is to write down that my point of intersection, which is my x and my y, is 3, 10. Let's practice another example of elimination using these 2 steps. So right now for C, I've got 4x minus y equals negative 1, and negative 4x minus 3y is equal to negative 19. So you're going to have to determine which one of these 2 variables you can eliminate. Is it going to be my x's or my y's? It'll definitely be my x's because my x's are both 4's. One is a positive and one is a negative. My y's don't have the same worth. One of them is a 1 and the other one's a 3. It'll never become a 0. So right now I'm going to add or subtract to determine how I'll make a 0 for that x value. So let's try adding first. 4 plus negative 4. Turns out that it becomes a 0. So right now I know that I'm going to add all of my variables or all of my like terms together. So we'll start off with negative 1, and if you need to, write that in for that y so that you don't forget it. Negative 1 plus negative 3 is negative 4y. And then we'll collect the constants. Negative 1 plus negative 19, which is negative 20. Then we'll eliminate this 4 by performing opposite operations. So we were multiplying by negative 4, so we'll divide by negative 4. A negative 4 goes into a 20 5 times. And it's a positive 5 because a negative divided by a negative, the 2 negatives cancel out. So now we've just done step 1. This is why I'm saying that substitution is easier because there are less steps. Step number 2, which is our final step, is to choose an equation and substitute that 5 in for y. So let's choose, it doesn't matter which equation we choose. I'll choose the first one. 4x minus 1y is equal to negative 1. And right now we know that this y is 5. You have to be careful with that negative 1. Don't just get rid of it. So 4x minus 1 times 5 equals negative 1. 4x, negative 1 times 5 is negative 5, equals negative 1. We'll collect the like terms by bringing over the negative 5 to leave my 4x by itself, and I'll have negative 1 plus 5. Negative 1 plus 5 is 5 minus 1, which is 4. Divide both sides by 4, and we'll end off with x is equal to 1. So right now we've solved for our y and our x value, for our point of intersection, which we can write down as 1, 5. But now we're going to get a little bit more tricky. So let's look at example C, or B as it's listed in error, and we'll see that we've got 4x minus 2y equals 6, and x plus y equals 6. So I'm going to choose to add or subtract. But if I look at these variables, 4 and 1, 2 and 1, those will never become a 0. So then I have to add another step to make them the same. So here's what we're going to do. We're going to take the first number in our equations and multiply them by each other. Then they'll become the same variables. So what I mean by that is that for the first equation, the one on the top, the 4x minus 2y, I'm going to multiply all of the terms by the opposite, which is 1. And then I'm going to multiply all of the second equation terms by 4. When I do this, when I multiply the first numbers by each other throughout both of the equations, this is going to cause the variables at the front to be the same. So let's check it out. 4x times 1 is 4x. Negative 2y times 1 is negative 2y. 6 times 1 is 6. So the first equation didn't really change. But now let's see the second equation. 1x times 4 is 4x. 1y times 4 is 4y. 6 times 4 is 24. Now I've created two equations that I can eliminate a variable for. And by multiplying the equations by each other, we haven't really changed the equation. All we've done is made it 4 times bigger or 3 times bigger. We've changed every term by the same amount. So the equation itself is still the same. Now that I can see that my first two terms are both 4s, now I can use my method that I'm used to of adding or subtracting to eliminate. So we can try to add first. 4 plus 4 is 8, so that's not 0. 4 minus 4 is 0. So then I'm going to choose to subtract my variables together. Negative 2 minus 4 is negative 6y. Then 6 minus 24 is negative 18. We'll divide by negative 6. And a negative 6 goes into an 18 3 times. Now I can use this 3 and I can go into my first equation, my second equation, and believe it or not here I have a third and a fourth. It doesn't matter which equation you substitute it into. Ultimately, choose the easier equation. For me, I can see as a teacher that the easiest equation here is x plus y equals 6. So that's the equation that I'm going to use for step number 2. X plus y equals 6. And then I'm going to replace that y with what I know it to be, which is 3. Then I begin to perform opposite operations by taking that 3 and bringing it over. 6 minus 3 is 3. So my x and y's are both 3. My point of intersection is 3, 3. Now let's look at another example of where my variables don't have the same coefficients and I can't eliminate right away. So we know that our technique is going to take the first term, take the number in front, and multiply them by the other equation. So for the first term, I'm going to multiply all of those terms by 2. Then for the second one, I'm going to multiply all of these terms by 3. And by doing that, it'll make the first 2 terms the same numbers. So let's see that in action. 3x times 2 is 6x. Positive 2y times 2 is positive 4y. 5 times 2 is 10. My first equation's done. Let's look at my second equation. 2x times 3, and here it is, 6x, now they're the same. 5y times 3 is 15y. Negative 1 times 3 is negative 3. Now we're going to do our method of adding or subtracting to eliminate a variable, and we know that with this method of multiplying the first terms together, that obviously the 2 terms that can cancel out are that 6x and 6x, because we made them the same. So now we're going to practice if we can add or subtract. If we do 6 plus 6, that's obviously 12. It's not going to work. So then we're going to minus to make that 0. 6 minus 6 is 0. So now we'll continue on and collect the like terms. So 4 minus 15 is negative 11y. And then 10 minus negative 3 is positive 13. Now we'll divide by negative 11. And then 13 over 11, negative 11, is not a whole number. It's not a nice number. So you can leave it as 13 over 11, or we can use the decimal. And if we use the decimal, as I told you before, I'm not too concerned with rounding. So right now, if I divide 13 by a negative 11, I'm going to end off with negative 1 point, I'm going to say 2, because it says 1.181818. So I'm going to round that 1 to 2, because there's an 8 behind it. So now when I substitute it, I can choose the first, second, third, fourth equation. I'm just going to choose the first one. So 3x plus 2y equals 5. And I know right now that my y is negative 1.2. So 3x plus 2 times negative 1.2 equals 5. 2 times negative 1.2 is negative 2.4. Equals 5. Then we'll take that negative 2.4 and bring it across. So then it becomes 5 plus 2.4. That 3x stays. 3x is equal to 5 plus 2.4, which is 7.4. 7.4 divided by 3 gives me a value of 2.5. I'm going to round that. So 2.5. So right now I know that my x is 2.5 and my y is negative 1.2. Sometimes the numbers don't work out perfectly, and that's okay. We know that we did this correct. Now I want you to practice E and F on your own, and then check your solutions against mine in the filled in notes. This third lesson concludes the unit.